Hey guys, I'm Dr. Cadell, and this is the specific heat capacity lab. The general idea here is that we're going to determine the specific heat capacity of an unknown metal. To do that, we're going to use this equation right here. Really simple equation, guys. Remember, Q stands for how much energy goes into or out of an object. So what this equation says is that the amount of energy that goes into the water is equal to the amount of energy that comes out of. That negative means it comes out of the metal. Because what we're going to do, pretty simple, we're going to take some metal, heat it up, measure its temperature, see how much it weighs too, put it into some cold water whose temperature we know and whose mass we know, and from just those measurements right there and the final temperature, we're going to be able to figure out how much energy goes into the water, and that means how much energy came out of the metal. Now, knowing how much energy came out of the metal, we get to use this equation right here, because these should be familiar. Q equals ms delta T. This is how we're going to figure out how much energy goes into the water. Q of the water is equal to the mass of the water times specific heat capacity of the water times the change in temperature of the water. So we're going to know all these things once we get our measurements, which means we'll know this number right here, which means we know this number right here. Knowing this, we're going to know everything here except for this. S stands for the specific heat capacity of the metal. So we're going to end up being able to calculate that, which is kind of the goal of our experiment. Now, real quick, the delta T's here, it's always the final temperature minus the initial temperature. So for the water, it's the final temperature minus the initial temperature of the water. For the metal, final temperature minus the initial temperature of the metal. Notice these are the same. They're going to end up at the same temperature. So here we go. So, specific heat capacity, there are some numbers we need to make sure we get. One of those is the mass of the metal. Another is the mass of the water. The initial temperature of the water, initial temperature of the metal, and the final temperature. So, the unknown comes in a test tube like this. Now, if you're just watching this video at home and you're going to do the lab report there, you won't have an unknown number or anything like that, but this is what it looks like. The unknown number is on there. Usually what we do is we take it off and tape that in our data table because that's an important number usually to know. So the mass of the metal. What we do is we take a 150 milliliter beaker, put it on the balance, and tare the balance. Should read 0 with the empty beaker on there. That way what it's doing is it's subtracting the mass of the beaker for us. So we take the beaker off because we never pour anything directly onto the balance, and carefully, so as not to break the beaker, we pour the metal into the beaker. All the metal shot, put it back on the balance, and that number that we read there, it's the mass of the metal, and that's going to be your A2 in your data table. Once we have that, take it out, and again, carefully pour the metal shot back into the test tube so we don't break the test tube. And now what we're going to do is we have a beaker of boiling water over here on the hot plate. We're going to take a ring stand and a clamp and clamp the metal into the boiling water all the way down, submerge all the way down. Clamp it on here and then lower it down. We don't want to touch the bottom of the beaker, but we want to get it all the way submerged. Now we're going to let that sit over there and heat for a while we take a couple of other measurements. Another measurement we said we need is the mass of the water. So this is your calorimeter, and this is the tool that you're going to use to do this experiment. Now it has a lid, comes off like this, and inside this calorimeter looks like this. There's a metal cup in here, it comes out, and there's a styrofoam insulation inside here which we're going to keep in there. This is where the water is going to go, and eventually the hot metal is going to go in there too. What we do, okay, I have about 80 milliliters of deionized water that roughly 80 mils that I measured out before. The actual volume doesn't matter, guys, because what we're going to do, what we need to know, is how much the water weighs. So we take the cup from the calorimeter, put it on the balance, close the door, tare the balance so that it subtracts out the mass of the cup for us. Take it out. So it says 0 with the empty cup on there. Pour the water into the beaker. Excuse me, not the beaker, the cup. Place it back on the balance. Close the door. And that number that we read there, that's the mass of the water. And that is going to be A3. And now you guys, we do this experiment, we run through it 3 times. The first time through, it's all A3, A4 like that. The second time through starts with B, B3, B4, and then third time C3, C4. So when we go through the second time, that number right there will be B3, and then the third time will be C3. So we take it out. Now place it back into the calorimeter. Now we need to know the temperature, the initial temperature of the water. So we take our thermometer, digital thermometer, it's on degrees Celsius, hold it in there, let it come to equilibrium, read that temperature, 1 past the decimal degrees Celsius. That's going to be the temperature of the cold water in the calorimeter, A4, B4, C4. Set that there. To get the initial temperature of the metal, now it's a little bit indirect. We can't really measure the temperature very well just by putting the thermometer into the metal. It doesn't work very well. There's not enough contact, not enough surface area. So what we do is we measure the temperature of the water, the boiling water that the metal is in. The idea is because that metal has been in there for 10 minutes or so, that it's the same temperature as the boiling water, and it works really well. So we measure this temperature, 1 past the decimal degrees Celsius. It should be pretty close to 100, might not be exactly 100. That's going to be the initial temperature of the hot water, which is the same as the initial temperature of the metal. That's what you use to measure the metal. That's going to be A5, B5, C5. All right, so now we're about ready to go. When we're going to take the metal, put it into the water. Now we have to do a few things at once here. We're going to have our thermometer ready. This is the top to the calorimeter, and this cap covers a port that we don't use for this experiment. This is a mixer that we're going to use, and this is where the thermometer goes. I'm going to set that in there. Have this ready to go. Now I'm going to have my table to record the temperatures every 15 seconds. So time equals 0, we don't measure because we're doing stuff. But at 15 seconds and every 15 seconds after, we record the temperature. So looks like we're ready to go. Been 10 minutes, got all our numbers. Undo the clamp here. It's not hot back here. Up here it's going to be really hot. So what we do is we take this, dump it in to there, put this in, start agitating, and then every 15 seconds we record the temperature in our table. Go all the way through. All right, so we've been measuring the temperature every 15 seconds and filled out our data table. When we're done, okay, we need one more number, and you kind of get that in the calculations when you're doing your lab report. But the idea is that this temperature is going to stay pretty much the same for a while. The temperature that it stays at the longest, that's your final temperature, both of the metal and of the water. And that's the last number you need. So this will be one run through. You do it 2 more times for a total of 3. Now, after you finish each run, the last thing to know is we need to take this metal out. Now we don't need to weigh it again. We already weighed it, but we need to dry it off. So we pour out that water and then place it on some paper towels, get it as dry as we can, put it back into the test tube, and repeat the experiment 2 more times. And that's it, we're done.